Hello everyone. In today's video, I'm going to quickly go over just the reactions that you should know how to do and the reactions that you should just simply memorize. And this will be a very quick video. So starting from the first page, you should understand how to do this reaction. You should understand how to do this reaction. You should understand how to do this reaction. This reaction should be understandable. You don't need to understand this reaction right here. You should understand the first reaction, H2SO4 and heat. It would be nice if you understood this one, but it's not necessary. But it does help you with some concepts a bit. This reaction is you need to understand it. Oxymercuration, demercuration, you don't need to know how to do it, but essentially you already learned like the majority of the mechanism, and it's extremely similar to this X2H2O reaction. So you don't need to, but you already do if you know the other one, which you really should know. You don't need to know hydroboration. You don't need to know catalytic hydrogenation. You don't need to know any of these glycol synthesis alkene oxidation reactions. You don't need to know any of these, just memorize these. Alright? You don't need to know ozonolysis, how it works. You don't need to know KMNO4 cleavage. You just need to know the little details that change and just some little concepts that, this one oxidizes a lot more. It's a stronger oxidizer. So, this can form aldehydes. This one cannot, right? It goes all the way to carboxylic acid always. If it can, it does. You don't need to know how this works. You don't need to know how this works. You do really need to know how these two work. This will come back in Orgo 2. It's like one of the first things you do in Orgo 2. So you really need to understand these. You do not need to know how to understand formation of dibromocarbenes. You do need to understand this. So this needs to be understood. This all needs to be understood. Some of it is things you already should know, but you really need to understand all this part right here. You don't need to know how to synthesis of alkynes from dihalide, vicinal or geminal dihalides, but I do show everything in the video. Everything that I say can or you don't need to know, I've shown it, right? I've explained how it works. So you don't need to know how it works, but it's pretty interesting, to be honest. You already kind of know the mechanism for this is probably not really anything crazy. It's pretty much more of the same. Triple bonds reacting with Br2. You've seen double bonds react with Br2. I'm sure it's very similar, right? And it's also when it comes, I'm sure it's I don't know if you can do this two equilibriums. I don't know if you can do that again, but for HBr for sure you can. You have you can go one equilibrium or two equilibriums depending on what is acquired of you or asked of you, and it's the same thing as double bond before. It's Markinson addition. So a lot of these are the same. This one's just with the peroxide, so it's anti-Mark. Another catalytic reduction with catalytic hydrogenation. The same thing. You don't need to know it. You don't need to know these, right? Hydrogenations with alkyne to alkene reductions. You don't need to know how these work. You just need to know, it's forms ketones. This one forms aldehydes. You don't need to know how they work though. Little things that are helpful, like H2O2 is a very nice hint to let you know that, okay, anti-Mark, because it's essentially anti-Mark. Least substituted carbonyl is the aldehyde. You don't need to understand how this works, right? The diols, right? Vicinal carbonyls, not diols, they're vicinal carbonyls. You don't need to know how, this is very similar again, cleavage of alkynes. So we've seen these already with double bonds. It's the same thing this time, except now they all do the same thing. So whether you're doing ozonolysis or whether you're doing KMNO4, it does not change anything. They both have, they're both equally oxidative, and they cannot stop at aldehydes. They fully go to carboxylic acid always. You need to know this, right? So you need to know the Grignard, how to form it. You need to, there's not really a mechanism to know, but you need to like kind of have some understanding that this is a C minus. You need to know, you don't need to know organolithium. It's essentially the same, just stronger. It works the same way. You need to know all these right here. You need to understand all these. If you understand the Green Reader and the way that I showed it, this should all be cake. Like, you shouldn't even have to like memorize these things right here, right? You should understand it, and with understanding it, you should be able to do all these. Same thing goes for this. Right, I've shown how this works. So this is this is an understanding one. This is an understanding, right? Do not memorize these. This is memorization right here. It's easy. It's not really memorization, but you know, you can memorize it. What's up? Oh, let's see. This should maybe be memorized, right? Corey House is memorized. These should be understood, right? Reduction should be understood. This is Raney nickel. Only difference is that now we have carbonyls reducing to alcohols, and we use Raney nickel specifically to do that. Let's see, and now we have these. This is also memorization, but it's more of just understanding the difference between which ones are strong oxidizers, which ones are not as strong, and which one's going to leave me with a hydrogen, which one's going to leave me with alcohol, with a carboxylic acid group, essentially. Let's see. And then I have OTOS. This is also partially can be understood, but just memorize this and make sure you're always paying attention to the rules on the side. There's some pretty helpful rules and conditions and exceptions. This just needs to be memorized. This needs to be memorized. These are all memorized. This should be understood, but essentially memorized. But you should understand it. This is just the E2 exception for SN2. SN2, yeah, whatever. Where a strong base can act in SN2. So this is essentially what this is. Forget the name. It's nothing truly special. This is something that you should just memorize. This should also be memorized. And this right here should also be just memorized. Okay, so that's your whole reaction sheet. A lot of memorization, but you can cut down how much you have to memorize a lot by actually understanding, and it's really not that hard to like the things that you understand, they're not that difficult. Okay, so best of luck with that, and try not to take too much time in getting to this. It does build up. All right, good luck.